Cantor's Intersection Theorem. In a complete metric space, let F1, F2, F3, and so on, be a nested sequence of non-empty closed sets, each contained in the previous, whose diameters shrink to zero. Then their intersection contains exactly one point. 4 key terms. A complete metric space is one where every Cauchy sequence converges to a point inside the space. A closed set contains all its limit points. The diameter of a set is the largest distance between any two of its points. Nested means each set sits inside the previous one, F1 contains F2 contains F3, and so on. The setup. Picture a sequence of closed sets, each nested inside the last, getting smaller and smaller. Their diameters shrink towards zero. The question is, what survives in the intersection of all of them? We will show it is exactly one point, no more and no less. Step 1. From each set Fn, pick any point xn. This gives us a sequence of points, one from each set. Now we claim this sequence is Cauchy. Take any two indices m and n, both larger than some n. Since the sets are nested, both xm and xn lie in Fn. So the distance between them is at most the diameter of Fn, which shrinks to zero. The sequence is Cauchy. Step 2. The space is complete, so this Cauchy sequence converges to some point x star inside the space. We now show x star lies in every single Fn, fix any n. For every index m greater than or equal to n, the point xm lies in Fn, because the sets are nested. So x star is the limit of points all sitting inside Fn. Since Fn is closed, it contains its limit points, therefore x star lies in Fn. Step 3. Since x star lies in Fn for every n, it belongs to the intersection of all of them. So the intersection is non-empty. Now uniqueness. Suppose 2 points x and y both lie in the intersection. Then for every n, both lie in Fn, so their distance is at most the diameter of Fn, which tends to 0. Hence the distance between x and y is 0, meaning x equals y. The intersection has exactly one point. Cantor's intersection theorem is proved. In a complete metric space, a nested sequence of non-empty closed sets with diameters shrinking to 0 collapses to exactly one common point. Completeness guarantees the point exists, and the shrinking diameter guarantees it is unique. This theorem is the metric space heart behind many deep results, including the Baire category theorem.